In this lesson, we are looking at creating confidence intervals from samples when the standard deviation for the population is not known. So if an SRS, or simple random sample, is drawn from a population that has a normal distribution with a mean mu and a standard deviation sigma, then the sample mean will have the normal distribution x bar and s, right, for a sample size of n. As n increases, the spread or variance decreases because the bigger our sample size, the smaller the width, the spread. But most of the time we don't know the standard deviation of the population, so we can calculate S, which is called the standard error. Problems were noticed when n was not large, and so this takes us to Ireland and William Gossett, who worked at Guinness Brewery. In case you didn't know, Guinness is a very famous Irish beer. And he was using an alpha of 5% to reject batches. So 0.05, he says, okay, I'm going to do my confidence interval on 5% of the time. I'll accidentally reject a good batch. But he realized he was rejecting 15% of the good batches, which for a beer company is not good when you're throwing an extra 10% of good beer away. So he actually collected a lot of data, and he created a new model called the student's t-distributions. These are unimodal, symmetric, and bell-shaped, just like normal distributions, except they have fatter tails, larger margins of error, and larger p-values. So they use something called a t-value, which are like z-values, but they have a different model for each degree of freedom, and I'll show that to you in a second. As the degrees of freedom increases, this distribution looks more like the normal distribution. So quickly here, I have a Geogebra applet, and you can see there's the student's t-curve in red and the normal in blue, and I'm playing with the degrees of freedom. And you can probably see there's a spread growing right there, yeah, both of us pointing to it. And then finally, as we get down to 1, you'll notice that, oh wow, these tails are definitely fatter over here. So more of my data is further away from the mean. We have greater spreads with the student t-distribution. So how do we calculate? One thing we can do to do confidence intervals, you remember we had to calculate a critical z value, and now we need to calculate a critical t value. It's almost identical. So you're basically going to press second distribution on your calculator just like you did before. Then you're going to scroll, instead of inverse norm, you're scrolling to inverse t. You're going to put probability like we did before, and this is for, let's see, this is probably a 98% confidence level. And then you put in the degrees of freedom, and it'll spit out a number. So this returns a t-value at which probability to the left is the entered value and the specified degrees of freedom. Okay, so here I'm doing another one with a larger degrees of freedom, and you can see here that my t-value is smaller when I have larger degrees of freedom. So that's an interesting thing to note. So let's go ahead and calculate 2 t-values on our own. This is the example in your notes. I want a student's t-distribution to find the critical value of t-value with an 80% confidence level when the sample size is 32 and when it's 64. And you can see I'm using the same confidence level for both. Now, I'm going to tell you right now, I'm going to put this in the calculator, and it's actually going to spit out 1.31. Now, most of the time, students, first of all, where does the 31 come from? Well, you take the degrees, the n, and subtract 1, and that's your degrees of freedom. So 32 minus 1 is 31. Usually the bigger question I get is, where'd you get 0.9? Well, if I were to, let me just crudely draw it here. If I were to draw a normal distribution and I want 80% in the middle, right? 80. Pretend I can write 80. Then how much does that leave for the front? Well, I've got 20% left over. I got to divide it in half. There's 10%. I want this piece, which is 90%. So I'm going to show you how to enter it in the calculator here. And you go second distribution, inverse t, which is 4. Then I'm going to have 0.9 and 31. For the other one, the only thing that changed was the sample size of 64. And so there, I'm going to do inverse t of 0.9 and 63. Remember, I'm subtracting 1 for the degrees of freedom. And the 0.9 came because there was 10% in front of the 80%. And so what do we notice about both of these values? This one's 1.31, there's 1.30. We didn't see a big difference, but there is a difference. Which is larger, the t-value with fewer degrees of freedom. Remember, as n got small, my spread and my tails got wider. Now let's go ahead and take a look at a coffee machine. I know you can't see the whole thing, but basically I'm going to go ahead and calculate the sample mean, coffee ounces, and standard error. And basically, you can just enter all this data in a list. We've done it before. So I'll get all these in there. I'm going to do this very quickly because it's just stat and edit to get into your list. I think I have about 20 points of data on this. And then once I get my list entered, I'm going to go to stat again, and then go to calc and one var stats. And one var stats, I don't have to hit a list because it was list 1. If I use something else, I do need to tell it which list. And you can see that there's my readout from the calculator. I can actually calculate my mean and my sample mean, which is this 0.1986. All right. Now, if I go through the mechanics of it all, basically, there's my average, there's my S, and I pulled it from this part. There's my N, there's my degrees of freedom, and this should look familiar to you. Doing standard error, I take that and divide by the square root of N, and this is what I got. I'm going to calculate the critical value, and I get that. Then my margin of error is the critical value times my standard error. It's like my standard deviation, but for a sample. And then my confidence interval, I'm going to add and subtract that product. But wait, there's an amazing shortcut. Are you ready? So to basically, let me go to next slide. To enter the data in the list. Okay, so you're going to basically press stat and edit. And after you get the data in the list, you're going to press stat. You're going to scroll to something called test and select 8, T interval. Then you're going to select data because we're going off of a data list and press enter. Make sure you have list 1. And if you need to change, if you didn't put the data in list 1, you can press second in list to pull that in. We're going to put in the confidence level. So this, I don't have to do this 0.9 from 0.8 thing. If I want 80%, I put 80%, 0.80. And then calculate. So for our example, watch this. So I'd already calculated one var stats. Now I'm going down to 8, which is T interval. And there's data. Make sure the data is highlighted. There's my confidence level. And then hit calculate. And voila. By the way, you can also use this shortcut for a Z interval. But remember, a Z interval is when you know the population standard deviation. There's also a way to do this with just the stats, so you can actually enter in the X bar and the S if you're given it in the problem. So there are lots of nice shortcuts on your calculator that are worth